The last topic of this chapter is power. Let's motivate the definition of power. And the idea is that if you, let's say, for example, have an object that you want to raise to a height. So let's say this is 10 kilograms, right? So now depending on the person you ask, let's say you ask a kid and you want to, let's say, raise it to this height. The kid is going to take a longer time. A healthy adult would do this much quicker, right? So there's obviously a delta t, like a time involved for a person to pick this object and raise it to a height, to a certain height. So the smaller the time the person takes, the more the power output is, and it's intuitive, right? The stronger the person is, the smaller the time. Or if you're using a machine, for example, the more power the machine has, it's going to take a smaller time. So power is therefore the ratio or the rate at which work is done by a force. And instantaneous power is the derivative of work with respect to time. So this is when, let's say, work is given as a function of time, you can take the derivative of work and find the power. So work, we know, let's look at the units, is joules, and time is SI unit is seconds. So 1 joule per second is what we call 1 watt. Another typical, this is not typically used, it's just a conversion factor for feet and pound per second. So another common unit is horsepower. 1 horsepower is 746 watts. Now we can derive another equation for work. So we know that a differential amount of work or a small amount of work, dW, can be written as force time the parallel component of force times the displacement. Now dx by dt we know is a velocity, right? So you can replace this with velocity, and therefore you get P equals FV cosine theta, which is just this part is just the dot product of force and velocity. So this is just an equation to get the instantaneous power for a force. Okay, let's look at a question. So you have 4 different situations over here. 4 students running up the stairs in the time that is shown. The time is given 10, 8. So the student takes 10 seconds, 8 seconds, 8 seconds, and 25 seconds. And students have these 3 students have the same mass, but this student has a different mass. So you have to find the power output in each case. The height for these students is given 10 meters. This is 20 meters. So pause the video and think about it. So the answer is B. Now, power is again the work done divided by the time, or it's also written as delta E. So remember the work is also given by the change in the energy of a system. So you can also write it as that. So delta E in this case, when the student goes up to a height, let's say, and stops, the overall change in the energy of the student is mgh, right? And then that's divided by delta T. So if you plug in the numbers, the mass, G is 9.8 meters per second squared, H is given, you'll see that this student has the maximum value for power. Okay, another equation that is used, not another equation, it's the same equation, just written in a slightly different form that you'll see. And this is in particular for like energy consumption for electrical equipment in your home. So when you look at your electricity bills, you'll see that they're typically given in this unit, kilowatt hour. That's actually a unit of energy. So power is kilowatt and T is in hour, right? So the unit is kilowatt hour. So if you plug in the power that power consumption for a particular equipment and then multiply it with the time, you can get the energy consumption, and you can also get the price per kilowatt hour from the company, and then calculate the total cost. Let's look at this example where this is done. So this example, you have to find the cost of running a 0.2 kilowatt computer. So it's a computer that's power consumption is given by, that consumes 0.2 kilowatt power, and you run the computer for 6 hours per day, right, for 30 days. So this is the cost of electricity, right? So what is the total cost, right, of running a computer that consumes this power for 6 hours per day for 30 days, and its power consumption is given by this. The price is given by this. So the way you do it is you have the time, right? So let's figure out the total time that you have used for the equipment, for the computer. So 6 hours per day multiplied by 30 days, you get 180 hours. So this is the time you have consumed. So we need, obviously, we're using equals PT. You need the time. So we figured out the time that for which the equipment has been used. Power is 0.2 kilowatts. So you can use that 0.2 multiplied by the time to get 36 kilowatt hours. Now the cost is 0.12 per kilowatt hour, and you have the total kilowatt hours you've used. So you just have to multiply the kilowatt hour with the cost, right? So this is the cost per kilowatt hour, right? And this is the energy, the energy given in kilowatt hours, right? So you just have to multiply the two together. So this is the E, right? So when you do that, you get $4.3 per month. So this is this can give you an idea of how much bill do you get for a particular equipment in your house. Okay, so that was it for the chapter. Make sure you are solving the worksheet. The worksheet, again, is very important because you might see a question from the worksheet in the quiz, or the questions that the examples or the multiple choice questions we do in the videos. Make sure you go through these and you understand the questions, because you might see a question in the quiz from these questions.